Section 8.5 deals with the area of parallelograms. And, we've already talked about the area of a square and the area of a rectangle, which are parallelograms, and they have their own formula. But if we just have a general parallelogram, we have a formula for that as well. So if we look at these two diagrams, before we even look at the formula, we need to know what the base and the height is. So in this first parallelogram, this would be the base, and the height is how tall it is. Okay, so we actually have to draw in the height just like we did for a triangle. And remember, a base and a height always make a right angle. Okay, you could draw it on the outside of the triangle as well. This would also be the height. Notice that those two heights are the same, so it doesn't really matter where you draw it, it's just the distance between these two opposite sides here. So in this parallelogram, this here is the base, this is the height, because that's how much distance there is between the two sides. Okay, it is not the slanted edge on either of these. That is not the height. You want the distance between those two sides. Okay. Now for a rhombus, that's a special parallelogram, so it's going to have a special formula. We need to look at the diagonals of a rhombus. Now the diagonals are going to go through the rhombus and connect the vertices. So this is a diagonal, and this is a diagonal. And it doesn't matter which one you call diagonal 1 or diagonal 2, but in the formula, that's how we're going to label them. Remember that your diagonals of a rhombus are perpendicular, and because it's a parallelogram, they do bisect each other. Okay, so let's talk about the formulas. The area of a parallelogram is simply base times height. So that is very similar to a rectangle, but the base and the height are at a different place because, remember, the base and the height have to make a right angle. It is not the slanted edges. The area of a rhombus is 1/2 diagonal 1, diagonal 2. So meaning 1/2 times diagonal 1 times diagonal 2. You could also write this as diagonal 1 times diagonal 2 divided by 2, because multiplying by half is the same thing as dividing by 2. Okay, so example 1, find the area of the parallelogram. Area is just base times height. So we have 9 times 6, so we have 54 meters squared. Again, area has square units. Example 2, the area of a rhombus. Notice that they are telling you how long the diagonals are on the outside of the figure, but that's okay because this height, or this length right here, is the same as this. So we know that it's that diagonal is 14. We know that this diagonal is 10 because it matches this as well. So area equals 1/2 diagonal 1 times diagonal 2. So we have 10 times 14 times 1/2. And again, it does not matter what diagonal is number 1 and number 2. 10 times 14 is 140, and half of that is 70, so 70 inches squared. Example number 3, find the height of the parallelogram. Okay, we are starting with a parallelogram, so we're going to start with area equals base times height. Plug in what you know, and then you can solve for what you don't know. The area is 78, the base is 12, and this time the height is what we don't know. So in order to solve that, we're simply going to divide 78 by 12, and we get 6.5. 6.5 feet. Notice this is just feet, not feet squared, because it's a height. It is not an area. You are now responsible for checkpoints 1, 2, 3, and 4.